So again, for calculus, right, exponential functions and the graphs of ln functions are stuff that you just need to be able to visualize. No matter, you know how like when I say sine of x, you can visualize a graph? It should be the same for like e to the x and ln of x. So we know that e to the x has a horizontal asymptote, okay? So is there a x-intercept? No, it never crosses the x-axis. The y-intercept, right? Y of 0 is e to the 0, which is 1, okay? And then, you know, so that just looks like that, okay? You have to know, like, basically what it looks like. Most of the time, you know, when e to the x is involved, you'll have your calculator available because, you know, there aren't much calculations with e that you could do, you know, like exactly by hand, okay? And then e to the x plus 1, right? This time everything is moved up 1, okay? And so it looks like that, okay?
If it was negative, would it be this way?
It would be, if it was negative, like negative, it would be negative, the y-intercept would be negative 1 instead of positive 1. So it would go like this. So this is y equals negative e to the x. Okay? Now, ln of x is the inverse of that blue e to the x. Okay? So instead of a horizontal asymptote, it has a vertical asymptote. And instead of an x-intercept, instead of a y-intercept, it's got an x-intercept. So when y is 0, okay, when y is 0, when x is 1, y is 0. So that's the x-intercept, okay? And it looks like that. Okay.
Wait, why is y 0?
Huh?
Why is y 0?
Because, okay, so what's ln of 1? 0. Because remember the, what do you call it? The base of the ln is e. And the answer to any logarithm is the exponent. So what we're looking for here is the exponent of e that would give you a 1. And because e to the 0 gives you 1, ln of 1 is equal to 0. Okay? All right. That's as far as this. So from this, we're going to move on to the other handout. Okay, so this is both a and b is expressions that we need to simplify, and they're both from chapter 12.3. All right, where we did like f of x plus h minus f of x. Okay, so we can do that rather quick. There is no limit here. We're just simplifying, okay? So it's going to be 1 plus 2h squared, 2h plus h squared minus 1 over h. 1's go away. 2h plus h squared over h. You can cancel an h from everywhere, so that's just 2 plus h. Okay? I know it seems lengthy, but like I've left way too much space than I should have. Okay? All right, here, let's do the same thing. We got 16, 4 plus 4h plus h squared minus 16 times 4. That's 64, right? Over h. So this is going to be 64 plus 64h plus 16h squared minus 64 all over h. 64's go away. 1h goes away. 64 plus 16h. Okay? Okay. Next, we've got another situation. Okay? The situation is we've got like quite the complex fraction here. All right? So there are lots of ways to do it. One way, which is quite, like straightforward, is you go to the numerator, right? Like that's where the complicated part of this is. So basically, we have to do common denominator here, right? What I would do is, what is the denominator? What is the common denominator of that top over there?
2 times 2 plus x.
2 times 2 plus x. So you multiply that by 2 times 2 plus x and you distribute. But you've got to do the same thing to the bottom. So this becomes, okay, when you multiply this into the first one, you just get 2 minus 2 plus x, right? Because the 2's go away. Over 2x, 2 plus x. So in the numerator, that will be 2 minus x, which is negative x, over 2x, 2 plus x. X's go away, negative 1 over 2, 2 plus x. This is all because, right, next year in calc, when you have to do these, and it's just like one step out of like a 6-step problem, you should not, like, you know, get stuck on this. Yeah?
Wouldn't it be 1 over x times 2 plus x?
No, because the x's cancel.
But isn't it 2x?
It's 2 times x. Okay, so if you have x over 2x, what happens? X times 2x. Okay, so how about this? If you had 3x over 2x, the x's cancel, so you just have 3 over 2. Right? So 1x cancels with 1x. You just have the coefficients. And over there it was 1x over 2x, so you just have 1 over 2 left. Okay. What do we have to do here?
Do the, what's it called? The opposite, like the multiply by the, I don't know what it's called, conjugate.
The conjugate. So you have to rationalize, right? So you have to rationalize and multiply by the conjugate. Okay, so we're going to multiply. And what is the conjugate here?
Root a plus h plus root a.
Right, over the same thing. So that becomes difference of squares. So it's going to be a plus h minus a over h times root a plus h plus a. Okay, we're going to have a similar situation here. The a's go away. And with the h's, I cancel them. So what am I left with in the numerator? 1 over, this is root a plus h plus root a. Okay, now, this one, solve for x. Oh, okay, yeah, what the heck, right? Okay, let's just, okay, rather than freaking out, let's look at this. Just look on the right side of the equal sign. So ln of 1 is what, by the way?
E.
ln of 1, 0.
Oh, 0.
Right? So ln of 1 is 0. ln of e plus 1 is ln of, okay, so e is 2.7, right? E plus 1 is 3.7. ln of 3.7 is essentially just some decimal number, right? So that's a number over e, which is another number. So this whole thing here is just a constant. But basically, once that goes away, the ln of 1 goes away, what I have is 1 over x plus 1 is equal to ln of e plus 1 over e. And now we need to solve for x plus 1. So what do you guys suggest we do? Don't do it yet, but what do you suggest we do? That's always the first thing that hits us, right? But there is another way. There is another way. So look, as long as you have a single fraction equals a single fraction, okay? Proportion rules say if you flip one fraction, you can just flip the other fraction. So if I flip this, all I need to do is flip that, which means I could just do x plus 1 over 1 is equal to e to the ln of e plus 1. What? Really? Yeah. So then, that's just x plus 1. I mean, this is an extra step that I'm writing here, right? And then, so now how do I solve for x? Just subtract 1. E over ln of e plus 1 minus 1. Okay? And I'm fine with leaving it like that because I know you can plug it in the calculator. That's not the point. The point is to get it to that point. Because if this showed up on a multiple choice test, that's probably how it would be given to you in the answers. Okay. You guys remember the factoring?
Oh, yeah. Was that this semester?
It was this semester. You can never have enough.
That was like a long time ago.
Yeah,
That's why
everything's a blur.
we have to do it again and again and again, because if we do it one time, then next year you still won't remember, right? So it's not just, it's like repetitions over and over and over again, you know. Anyways, so we got a factor. So let's remind ourselves. When I have 5x to the 4 plus 3x to the 3, what do I factor out?
X to the 3.
X cubed y?
Because it's the lowest degree.
It's the smallest exponent, right? So here I have 1 plus 2 to the x to the power of something, 1 plus 2x to the power of something. Well, I can factor out 1 plus 2x to the power of negative 3 over 2.
Oh, I do.
Yes, see? Okay, so then I have negative x, because the other stuff goes away, plus 1 plus 2x to the power of what?
You multiply. No, you do. Wait.
Okay.
You do something.
You do something. So it's like we're dividing by this.
Wait, isn't 3/2 bigger than the...
Negative 3/2.
Yeah.
When you're dividing, what do you do to the exponents? Subtract them. So it's going to be negative 1/2 minus 3 over 2. So this is what? Okay.
1, 2. Wait.
So first of all, it has a negative exponent, which we never want negative exponents. So it's going to be 1 over 1 plus 2x to the 3 over 2 times negative x plus 1 plus 2x to the 1. Okay? But then we can simplify that further, because it'll be negative x plus 1 plus 2x over this. And look, it simplifies even further. It's just x plus 1 over 1 plus 2x to the 3 over 2. Okay? Cool, right? Okay, so next, what are we going to factor out?
X cubed plus 1 to the negative 1/2.
Right.
It's an aggressive call.
Oh my God. Okay, so we have 3 over 2, x cubed. Okay, and then what happens to this term?
Goes away.
Goes away. Plus x cubed plus 1 to the power of?
1.
So it's 1/2 minus 1/2, which is 1.
Wait, why is it that?
So because, again, we are dividing by what we factored out, right? And if you have the same base, different exponents, you have to subtract the exponents. Yep. So let's see if we can do this. Let's see if we can combine some steps. So the x cubed plus 1 to the negative 1/2 has to go to the bottom. It'll be x cubed plus 1 to the positive 1/2. 3 over 2 x cubed plus x cubed plus 1. Okay. And this we can also simplify, right? Yeah? So 3 over 2x cubed plus 1x cubed is 5. Okay, so here's what we're going to do. Again, we're going to do the same thing. This, what's the common denominator for all of them?
1.
The common denominator.
Oh.
So this is 3 over 2 times x cubed over 1.
Oh,
so
2.
it's 2, right? So these are all over 1. So the common denominator would be a 2. So let's multiply top and bottom by 2 again. So this will be 3x cubed plus 2x cubed plus 2 over 2x cubed plus 1 to the half. Finally, 5x cubed plus 2 over 2 root x cubed plus 1. Okay? All right. And that's that. So, yeah.
Wait, why? What is this?
Well, it's x cubed plus 1 to the power of half.
Okay.
So it's to the power of this. Okay, so the homework for this is worksheet D, which I'm going to give you right now. And it contains, you guys got worksheet C, right?
Yeah.
You did it last night. So worksheet D is this one, and it contains mostly what we did here. I'm assuming, you know, the EA to the X and the ln of X, like, you don't need to practice, right? You'll just know how to do those. Okay, so that's that then.